In this video, we are going to see about the adders. On the completion of this topic, students will be able to study what is meant by the Manchester carry chain adder and also the worst case delay of the ripple carry adder. So first one is adders. So adders is a digital circuit that performs addition of numbers. So mostly this adder has half adder as well as full adder. So in the case of the full adder, it adds 3 single bit input and produce 2 single bit output. So it is very essential, or it is very useful when the extra carry bit is available from the previously generated results. So here this will add together the 2 bits and gives the result as an output. These bits being added together are called addends, and adders can be concentrated in order to add together two binary numbers of an arbitrary length. And next is the inversion property. So the inversion property states mainly that full order stays the same if the inverse of all the inputs and outputs, if I is the inverse of all the inputs and outputs. So the major principle is it adds the 3 inputs and produces 2 outputs, and this first 2 inputs are A and B, and the third input is an input carry. So this carry contains C in, and the carry is designated as C out, and the normal output is defined as sum. So the major thing is how we are going to reduce this inverting stages is, first we are exploiting the inversion property, and we are reducing one inverter delay in each full adder circuits. So here you can see the major things of this inversion property is, this inversion property is based on the adds the 3 input bits. It cannot handle more than one carry bit from the previous state, so both the circuits are limited to the addition and can perform the other operations such as subtraction or the multiplication. So this adder adds 3 1 bit binary numbers, and also this is considered with a half adder which adds the 2 binary bits. So the major thing is here we can simplistically relate to design and implement, making the most efficient part, and it is speed and it contains low power. Next one is mirror adder. So mirror adder is nothing but it adds this mirror adder, the PMOS and the NMOS networks are equivalent to each other for both the sum and carry outputs, and also this leads to fully symmetric circuit topology. So in the case of the current in both the PMOS and the NMOS symmetric network is equal, and mirror of each other is fully symmetric with each other. So this is the form which is created by the 4-bit ripple adder, and it can be this mirrors reverse the direction of the image, and it is equal to the opposite angle from which the light is coming. That is, this can allows the viewer to see themselves or the objects behind them, or even the objects that can be angled from them, but it could not be a field of the view, such as it can be a corner. So this is used in the case of NMOS and PMOS. This NMOS and PMOS chains are complementary, completely symmetrical, and it contains the maximum of 2 series transistors. It can be observed by the carry generation circuitry. So when laying the cells, it contains the minimization capacitance, and also this capacitance can be connected to one another, which is placed closest to the output. So you can see this in the diagram here. It contains the 24 transistors. So it contains the 2 things, one is propagate and another one is generate. So it explores the self quantity of sum and carry functions. And next one is carry bypass adder. So carry bypass adder is nothing but a carry, it is also called as carry skip adder. So it improves the delay. That is, if you are sending some information, the major thing is this will increase the speed of the addition by propagating a carry bit around a whole adder, and also the delay between this is very less well compared to the other RCA methods, but its power consumption is similar to that, same as the RCA method. And the major disadvantage is it can skip carry only when all bits are in the propagation condition. It is not sure that always every bits are in the carrier condition, carry propagation condition, but if it is not in the carry propagation condition, this will get delay. Otherwise, if it is in the propagation condition, means this will be this propagation delay will be reduced. So this is one of the fastest adder which is used for the many data processing processors to perform the fast arithmetic functions. And also major thing is this will perform addition and multiplication in the very less times. And carry select adder. So carry select adder contains three steps. One is setup, generate and propagate. So this carry select adder is used to implement an adder which is logic element which computes the n plus 1 bit and n bit. So first bit and the next bit. The major benefit of this one is this achieves higher speed of operation at the cost of the increased number of devices which are used in the circuit. So here we are generating first the sum generation, multiplexer, I generate, B generate, and finally it is set up. So here it is shown in the bit is given in the form of sliced pattern. Bit 0 to 3, bit 4 to 7, 8 to 11 and 12 to 15. First the setup is given, next it is sum is given, and it is carry is given as 0 and 1. It is multiplexed and the sum is generated. So it is given in the 4 parts. And the linear carries also the same thing, it happens in the propagation and the generate form. So sum is generated in the form of the bit slice pattern, that is given as t add is equal to t setup of plus n by m into t carry plus m t max plus t sum. So here you can see the expanding low ahead equations. Quiz questions on adder, difference between the ripple carry adder and carry select adder. Thank you.